All right, well, I want to say thank you again to Sam Altman for participating in the summit and sharing his experiences, his vision, and his interesting insights. On a personal front, I'll tell you, I will take away the fact that he suggested using ChatGPT for parental guidance. I'm always looking for more information in that department. I especially look forward to asking ChatGPT about the appropriate amount of screen time for my kids. One administrative note, I know a lot of folks are looking for seats. We do have additional seating on the other side of these doors, on the other side of the hallway, out on the patio. Lots of comfortable seats. We have screens out there. You won't miss a single thing, so please feel free to take advantage of that. So that presentation set the perfect foundation for our first panel, which is entitled AI and National Security, Impacts and Opportunities, and will be chaired by retired Lieutenant General and Institute of National Security visiting scholar Ed Cardone. Lieutenant General Cardone joins the Institute after 36 years of distinguished service in the U.S. Army, where he commanded the Office of Business Transformation, U.S. Army Cyber Command, and the 2nd Infantry Division. Now, I'm very excited to hear the panelists' views on Mr. Altman's presentation and to further discuss how AI is going to directly impact national security. To frame the discussion, I think it's important to point out that in February, the Trump administration released an executive order on AI, and this was followed up by a speech by the Vice President in Paris, where the goals of the administration were articulated. Make America the gold standard for AI and work closely with our partners to maintain that dominance. Decrease the regulatory burden that can stifle innovation. Ensure the freedom of AI systems from ideological bias and censorship. And finally, to focus on job creation and increase productivity. I think to most of us that sounds good and it sounds reasonable, but to actually accomplish such important objectives, don't we need a strategy that lays out exactly how we're going to accomplish those goals? What are the potential pitfalls of these goals? What issues are we not thinking about that will be critical to success or failure? Ed, over to you and our panelists to help us answer those questions.
Thanks, Tuna, and I appreciate it, and my honor to follow Sam Altman. That's always a great presentation, and we have a great panel here to further the discussion on the impacts and opportunities of AI. So briefly, just like to introduce the panelists. We have Admiral Retired Mike Rogers, the former commander of U.S. Army, or U.S. Cyber Command, and
damn it, I was a sailor, mister.
I got you, Mike, I got you. And the director of the National Security Agency. We have Professor Jesse Spencer Smith, Associate Dean for Partnerships and Innovation with the College of Connected Computing, Chief Data Scientist, Director of Data Science Institute for Vanderbilt, and longtime friend Andrew Moore, who is currently the CEO of Lovelace AI. Now, I want to start off with, it's always hard to follow someone like Sam, but I took the point where he talked about this revolution in technology. And so I'd like to start maybe with you, Mike, you've seen the introduction of lots of new technologies over your long career and the different technologies.
That's code for because you're a really old guy. That's code
for technologies and concepts. But with AI, what are the advantages or concerns or fears from a national security perspective?
So first, selfishly, personally, thank you all for being here today. Thank you for your time, and it is great to see so many shipmates. One of the things I love about coming here, this is like the national security / cybersecurity ecosystem, and many of us have spent literally decades working together. So it's great to see so many shipmates, so thanks very much. In terms of the broad topic, first, if I step back, let me start slightly differently. On the one hand, I'm a little surprised what I haven't seen AI do so far. And what I mean by that is the fundamental premise of AI is the technology will enable us to take existing data and knowledge and create new and additional insight that will accelerate learning and give us insight and knowledge that we don't currently have. And what I'm a little surprised at so far is most of the value that is generated, and it is generating significant value, there shouldn't be any question in anybody's mind, is largely around generating improvement in knowledge of existing functions, capabilities, techniques, and trends. One of the things I'm still trying to figure out in my own mind is, why aren't we seeing the rate of new knowledge that personally I thought we might? That's not a criticism, it's just an observation. One of the reasons I say that is because from a national security perspective, one of the things that you're interested in, you're trying to figure out what technologies that you want to invest in, how you want to integrate those technologies into your day-to-day, your broader conceptual, strategic kinds of things where you're thinking about the future, your research and development, et cetera, is how can you maximize the advantage? I find the biggest challenge so far is not the technology. The biggest challenge is the organizational construct and the culture that, well, wait a second, how did you come to this conclusion? What is the basis of this recommendation or this knowledge that you're making? I'm a little skeptical because this isn't my normal frame of reference. It's not what I'm used to. I found the biggest challenge so far when you're trying to integrate it into large organizations, several I used to be a part of when I was in government, but even now as I work in the commercial world, that how you overcome that cultural piece. Because even within the national security arena, while you might argue, yeah, but the imperative for us, we're talking about our nation's security. We're talking about sustaining economic advantage. We're talking about the safety and well-being of our citizens. Even with those imperatives, I'm still surprised sometimes by what I encounter in terms of the sucking of teeth of, I'm just not really sure about this.
Yeah, just picking up on that, Jesse, I'd like to ask you about this competitive piece. So you're a bit on the bleeding edge here of AI in the research community. You hear a lot about competitive advantage, and Mike just mentioned this. How do we do that?
So, and Mike, to your point too about being surprised about the generation of new knowledge, I think that we do see some of that, but it may be unequally distributed. So I think that we see that in scientific research, where we have new knowledge being created. But in terms of maintaining a competitive edge, we're in an interesting position here ever since the release of DeepSeek, where at one point we thought that we would have this technical moat, that you would need our technology and our chips to actually train the most competitive models. With the release of DeepSeek, we realized that wasn't the case. But then we had a very interesting follow-on with the advent of reasoning models. Sam mentioned that one of the inflection points that he experienced was 2024, December, when O3 reasoning model released its benchmarks, which just blew past AGI benchmarks, which existed at that time. So I think that our competitive advantage really is in building and training these reasoning models. So if we don't have an advantage because we hold all the chips, it turns out we do have a national strategic advantage. We have a storehouse of knowledge of how to train these new generation of reasoning models. We have institutions that are the storehouse of varied ways of reasoning, and we've been training young minds for many generations. That same skill set, that same collection of knowledge and how to train reasoning can be applied to train reasoning models. We know reasoning models work, but they don't scale right now, and they address a very narrow area. So I think that actually one way for us to stay competitive is to scale not only in the size of the models, but also scale in what's called the inference time or test time compute. This is allowing the models to think. We've got to train them better on how to think. We have to have the technologies and so the models can think faster and produce better results. We know that it improves. We've seen O3. Many of us here have played with O1 Pro. We know that this is a way to make huge advances. So I'd say let's invest in our strategic advantage.
So, Andrew, I'd like to go back to something Mike said about this organization challenge with AI, and you and I have had a couple of conversations on this, and maybe if you expand on that based on your long history in this space.
Very good, yes. So for some context, I previously ran artificial intelligence for Google Cloud. I got to know folks like the Admiral and the General and other people in the national security space, and eventually I decided I needed to leave Google to work solely on artificial intelligence for national security, which was the birth of Lovelace AI. And part of the reason for that is a lot of experience putting artificial intelligence into large organizations. It's a very hard thing to do, aside from the technology. Technology is actually difficult to get right. And I've seen so many technology blunders that terrifies me. But much worse than that is you are having a conversation with an organization, be it a large bank, large retail chain, large hospital system, or in some cases, divisions of national security, where you're walking in and you are talking about intense automation and something which requires not only the adoption of new technology, but the adoption of new workflows and new ways of working. And that is hard to solve. And it's absolutely not the case that me and my band of PhDs in artificial intelligence are able to solve those organizational issues at the same time that we're trying to automate something or give it superhuman capabilities. So the most that I learned about artificial intelligence during my tenure at Google was all about the organizational psychology of how to help an organization, which is, it's an organism of thousands, sometimes hundreds of thousands of people who've all got their own priorities and fears, help them figure out when there is a place where superhuman reasoning can save lives, how to get it in place.
So Mike, maybe going back to some recent examples of where we see this, like the Israelis are using, lavender and profit. We see the Ukrainians recently, the press reports on a fully automated attack. Now, it didn't have AI in the way that people think about it, but you could easily see how AI could become a big part of this pretty fast, given the advances. And then you have all these commercial advances. I think in every boardroom that you, I, and others sit in, the AI question will come up.
Yeah.
And so what do you think about this with national security? Like, how can we accelerate this? I mean, you talked about the cultural change, but look at what's going on around us.
So the first is all of this happens in a context. And if you're in Ukraine or Israel and Gaza, the context for you a little different than the context sitting here in the United States. In this new life, you're out, but you're never really out, it seems like. So I've done some stuff with NATO on the Ukraine side. I've done some stuff with the IDF about Gaza in the last year. And one of my takeaways after talking to those teams and spending some time on the ground with them is, number one, necessity is the mother of invention as a vehicle to overcome resistance to change and bias against change. It's amazing what you're willing to do when you think your back is against the wall. Potentially good and bad, but it's amazing what you're willing to do. Secondly, it's amazing to see the difference. I'll just pick the IDF as an example. Culturally, the IDF has historically viewed technology as a vehicle for them to help overcome some of the challenges they face within the neighborhood. From, hey, look, we're not going to be, if everybody combines, we're not going to be as large as them, so we've got to figure out what are some things we can do that potentially give us competitive advantage. And so technology is something that they have focused on for a long time. So the cultural bias in the organization is, just talking to them as warfighters, is we are very comfortable with the application of advanced technology in a warfare down to the tactical level. And secondly, this is something we actively are pushing because we believe it gives us advantage. So as I'm spending time with the IDF, and I was part of a small U.S. team of retired 4-stars, theater commanders, commander, and I was there as the intel and the fires guy, kind of. And you're talking to them from literally from the battalion fires level all the way up to the Air Force commander, as well as their targeting cycles at the divisional level and at the command centers. One of the things that surprised me was the level of combining AI with autonomy, where they felt very comfortable about, we believe that this technology generates knowledge and insight that gives us speed and scale, because they kept talking about, we got to to target faster, and we've got to target more broadly geographically and at much higher numbers. We've got to hit the adversary as soon as we become aware of them. Their broad premise, particularly in an environment in which they argued the adversary is living and operating in a dense urban environment in which they are constantly moving, and they're operating within an ecosystem that makes it very hard for us, applying the law of armed conflict and concerns about proportionality when it comes to strike decisions, and talking to them about, okay, so you've come to the conclusion that one of the best ways to get speed and scale is to combine this advanced technology with a high level of autonomy. Now, I'm comparing that to my own military experience in the DOT, where I'm going, wow. We always strive for speed and scale, but autonomy in the application of force, for us, that has always been a real line that we're just really uncomfortable with. We've done things like push authority down to lower levels, but we still have broadly always insisted there's got to be a human in the loop that makes a decision about, based on this knowledge that's been generated, are you comfortable with the application of force in this specific scenario? And what surprised me a little bit was the IDF's willingness to just harness autonomy to get that speed and scale. They felt that the human dimension, that the technology was so accurate and generated enough confidence in their minds that combined with proportionality, they should push autonomy down to a much lower level and reserve the human decision-making for different levels, perhaps not as low as. A construct that, as an American, as I said, I'm looking at this, sucking my teeth a little bit, going, wow, this is really different. I've never seen anybody do it at this speed, at this scale, and this level of autonomy. I think it goes to my previous comment, from a national security perspective, and I'll do even narrower from a purely military perspective, we're gonna have to think through not just the generation and application of the technology itself, but increasingly, what is the role of the human in that application? What is the role of the human in verification of that knowledge? What is the role of the human in the application of force? What sorts of checks and balances do you feel you need in your processes? And I'm not trying to diminish the commercial world from the world of national security, but from a military perspective, you're talking about applications that lead to potential loss of life and significant injury as well as damage.
No, I think I once had a conversation with Condoleezza Rice on this, and she made an interesting, I hadn't really thought about this before, but all technology eventually makes its way into national security and warfighting, and we have to figure out how to use it. But I want to pivot just a second here, Jesse. If you talk a little bit about, back to this competitive advantage, you can see there's political science and all this wrapped in here. What's the role of the educational institutions in this again, maybe taking a little different approach on how we maintain our advantage?
So the interesting thing is that you see some of the earliest adoption and the broadest use of AI in educational institutions. We're exploring how to use this and how to use this to augment decision-making and to actually use the tools to be part of our decision-making. And this is core to what you were just saying, and also is common across all uses. And I think that what educational institutions bring to the table is an awareness that the technology works best when it is augmenting decision-making. It's very difficult to do something which is entirely autonomous, but you can speed up the decision-making significantly. That's part of it. The other is to recognize that the models can do what they do, not because they're really complex code. It's not. It's actually dead simple. I could sketch out the basics through GPT-3 on a single sheet of paper for you, but it's the training. So it's the training data, the training on reasoning that makes the models, gives them their capabilities. And so that's the other thing that we bring to the table, is the ability to generate high quality training material and also to interact and to train these models. It takes a huge amount of compute to get them up to that first level. It's called the pre-training. But then after that, it's a different game, and it's the high quality of data that makes the biggest difference on whether you have a model which is going to be okay or one which is outstanding and can do things that other models can't.
Andrew, maybe you could follow up a little bit on that last one, but you and I had a discussion about, do we really understand this? Because a lot about risk is about understanding the technology, but maybe you could talk a little bit about the challenges with understanding these large language models and where we are on that.
Absolutely. So there is a whole field, of course, of safety critical engineering when you're building systems where human life is at stake. And there are a whole set of principles. We've actually used them in self-driving quite well for making sure that the system that's based on a neural model is held in place by an outside controller that is based on understood engineering principles. So I want to be clear, none of us actually understand why these large language models work. It is you can think of O3 or Google's Gemini as a empirical discovery that this thing works that no one expected, and there are not yet people in the world who actually understand how these things work. So what we're left with are things which are very useful, and I can talk more about some of the places where we've been able to use them to help get the knowledge we need in an emergency situation. They're very useful, but they are unconstrained by normal engineering principles, and that means you can't necessarily apply safety critical engineering principles to them. So what we are doing in worlds like national security or financial decision making, where wrong decision can ruin an economy and so forth, is there are conventional algorithms out there which fact check the assertions or statements made by one of these models. So if I am looking for, and this is a scenario that we're working with, if we're looking at maybe thousands of ships entering a region and there's a terrible explosion somewhere, a human analyst could spend a huge amount of time trying to figure out which of those ships was potentially inadvertently or intentionally involved in that explosion. What an AI can absolutely do is join billions of dots to try to figure out what is the most likely cause and get that quickly. But then, as it presents its answers, you have to have a secondary system which is looking at all the lineage of all the facts used in the inference made by the large language model before I even allow the results of the LLM to get rendered to a targeter or an intelligence analyst. So what I really appeal to the engineers in many of these hyperscalers is to use the principles of safety critical engineering. You have a not yet understood, empirically successful reasoning system. You have to tie it down with a conventional system built on engineering principles where the mathematics and probabilities are understood before you unleash it in one of these safety critical areas.
Hey, can I follow up on that? Because this is a lesson from cybersecurity to me. So when we created this hyper-connected, highly networked world in which we all live, in which data is so critical from a business perspective as well as from a lot of other perspectives, we did not consider defensibility, redundancy, and resilience as core design characteristics. That's not the way we built this thing. So, 50 years later, we find ourselves in a very different environment in which we created something in which subsequent concerns have come to a much higher level, and yet we're somewhat hindered by the fact, well, geez, we just didn't build it into the system. So as we're looking at AI, one of the things that, to your point, that really interests me are, so what are the core characteristics that we want to be mindful of from the get-go? Because one of the takeaways from the implications of what we did in cyber, it cost a fortune to go back later and try to bolt stuff back on from a defensive standpoint. That if we had built that into the model from the get-go, we'd be in a very different place. So as we think about AI, one of the things I think we need to be thinking about is, so what are the core characteristics that we want to be mindful of, that we integrate into our approach at the very beginning and not try to do 10 years later where we say, "Ooh, geez, we didn't think about that. Maybe we should have."
And maybe if I could follow up on that, Mike, often we have a broader term of national security, but a lot of people default immediately to the military side, right? And, after listening to Sam and thinking about this for a while is maybe this aperture really needs to be open with AI. It's like so revolutionary, it changes the framework by which we approach and the way that you see it being used in influence operations, the way he articulated it could be used in the medical field, the way this might be used economically. I mean, what are your thoughts on this, national security-wise?
I mean, for me, I go to, number one, it's emblematic of the way we've started today. We didn't choose to start this conference with, let's get some general or admiral up there. Let's get some senior government individual up there. We said, no, let's get a leader in the corporate world who is directly involved with development of this core technology. That's not by mistake to me. It is reflective of the government and others who are going to use these technologies in national security are not generating the technologies. We're users. It's the corporate world. It's the private sector that's going to develop them. So how we develop this relationship over time in terms of roles, how we collaboratively work together. The second point I would make is the way we define national security right now is way too narrow to me, to your point. I just think we need, one of the things you're seeing is that the world of technology, economic security, and national security are now all intertwined. You just see that in government policy. You see that in the way the world is reacting. And it's interesting then to see how these different cultures are going to work together. Now, it's a little dated now, and we're in a better place. But Project Maven, I mean, when I first met you and you're at Google, Maven starts with the government, with the DOD asking the following question. We are going to apply, the DOD, weapons, armed force against individuals in locations around the world. That is a given. That is an element of what the DOD does. We believe that technology can help us do that in a more precise manner in which much fewer innocent individuals are killed or harmed, much less physical damage is done. Hey, it was help us in the precise application of force. We're not asking you to tell us, should we apply force or not? That's a decision that we are going to make. We're asking you, once we make that decision, help us to do it more precisely. Initial corporate reaction, hey, we're comfortable with that premise. Let's start down this road working together. We start down this road working together. Workforce increasingly says, well, wait a second. We're not sure that we are comfortable with the idea that from our perspective, we are helping the military apply force and take human life. Hey, that makes us really uncomfortable. I just thought it was interesting because you saw these two cultures looking at the same problem, totally different. The government, the DOD is thinking, no, we're trying to be responsible individuals here. We're trying to apply force much more precisely. And the private sector looking at it going, yeah, but you're still ultimately about taking human life in the application of force. And hey, that makes us really uncomfortable. Now, we're not in the same place, but it is reflective to me of we're going to continue to have these cultural questions between us about what is one entity comfortable with versus what perhaps maybe a different entity has a different view. It's where conferences like this become very important. It's where the educational pieces we're going, hey, look, can we work our way through this? But we shouldn't be surprised. We got some work ahead of us in terms of how we're going to apply this technology, both how we're going to develop it, how we're going to apply it, and what's the systems that we're going to work through to make that happen. Because in the end, this is a human-driven set of efforts. Right. It's not some autonomous machine that's doing all this. It is motivated men and women applying their knowledge to try to identify and create this technology, and it's individuals who are also trying to say, well, how can I apply this technology more innovatively? How can I use this to achieve these outcomes that I want to achieve in the defense and support of the nation that I'm a part of?
Part of the challenge is that the very idea of handing over some of the decision-making, and I don't just mean in these critical situations, but in any situation, is difficult, and we're just learning how to do this. So for example, probably some of you have used OpenAI's deep research. This is a great example of an agentic tool where you state a problem, then you have a separate model. The O3 model is behind this, goes out and autonomously does research. This is low stakes, right? It does research and then reports back to you. And what I've noted, and other people have noted as well, that often it's good, but because it goes for 10, 15 minutes doing the research and comes back and you realize, oh, it missed a critical piece. It missed a paper, it missed an understanding, and then you have to go back and then guide it. And I've been trying to figure out how much guidance do I need to be able to provide. I really would like to get some feedback on what's happening and be able to intervene and say, oh, no, don't cite them. That's not the right people to go after. Use these other sources. It is that problem in the small and in the safer space. We need to wrestle with that and to figure out what works to support human decision-making and what can we make autonomous and then trust. So we're still very early days because we're just in the beginning of the age of agentic AI, where we give a little bit more autonomy to solve a problem for us. How far do you go? How do you guide? How do you make sure that you've pointed it in the right direction?
So Jesse, if you could just expand on that a little bit, and if you look at this as like a core technology that's going to underpin all disciplines, and the disciplines are increasingly interrelated with national security, what does that do to the education process? Like, how much do people need to know in each discipline to be able to ask the right question with inference models going forward?
So what's interesting is that there's a broad concern that by adopting the models, we begin to lose our edge. We no longer have to think as hard. But in actuality, it's moving our thinking up the stack. We need to be able to take that broad picture, the broad understanding. Take computer programming. I'm a professor of computer science. A broad concern in our field that maybe we don't program anymore. But in actuality, what I'm finding is that I need to be a better programmer, a better software engineer to be able to define those issues, to know whether it is headed to the right direction and to be able to give direction. I'm solving broader and more difficult problems with a broader scope than I was before. And that's where we need to go with education. So we can actually make sure that you can understand the full scope of what you're trying to solve. We spend a lot of time handling the simple stuff. Well, the simple stuff can be handled now. Now let's concentrate on the broad scope, and that's the challenge before us.
Yeah, I'm going to ask Andrew a question, but I encourage you all to start sending your questions in. The address is there on the screen. So Andrew, we've talked about where we are. Where are we going to be in 5 years? What does this look like? Given, in fairness, in fairness, we've had this discussion a few times. So go ahead, Andrew.
So, with the national security direction in artificial intelligence specifically, I think we are going to see much more work on artificial intelligence which understand actions and next steps of entities. So some of you may remember that things like GPT, these large language models, they were initially trained by learning to predict the next word in a document. And from that, they ended up coming up with these semantics of the actual meaning, or some representation we don't understand, of the actual meaning of discourse. The next stage, at least the one that I want to make absolutely sure the United States is first at, is understanding the behaviors of adversaries, innocent bystanders, and levels going down to individual warfighters, all the way through to mass movements during really complicated theaters, and artificial intelligences which are trained not just to understand the world based on lexical or word-based semantics and reasoning, but which are watching the kinematics and dynamics of huge, complicated sets of behaviors and using that to make decisions or quickly alert commanding officers or targeters or strategy analysts when there's something going on, which, because humans just don't have the attention span to look at it, a human would not have joined those dots for another 4 or 5 weeks. So I do see a world where, especially in national security, it's about training to understand big groups of behaviors among sometimes massed forces, sometimes among groups of 3 or 4 perhaps terrorists who are working together and trying to conceal the fact that they're working together. That's where I'm putting all my poker chips at the moment. Part of the reason for that is I did spend a long time figuring out what I would do if I was evil, and doing this for one of the other countries with a more totalitarian type of approach to doing this. I was very frightened by what I saw, and I realized we have to be building now to defend against it.
We have a few questions, so I'll start. First one, Andrew, this one's actually directed right toward you. Alongside investing in further developing and expanding scale of existing transformer-based models, should we massively invest in the research of discrete computing that is better per energy unit, generalization performance, if competition is safety depends on the quality and state of frontier AI technology?
That's a great question. There's a big debate at the moment about whether we need to be doing massive energy investments in order to deal with the fact that if we took the technology that we're using at the moment with 2025 models and just tried to grow them without any other innovations using the same energy to 2030, we would need massive nuclear power stations by almost every cluster of computers. So this question is pointing at the fact that when you look at the developments just in the last 24 months of both the training phase, and as Jesse mentioned, the inference phase of these models, some of the big hyperscalers have reduced the costs, energy costs, by a factor of up to 50 just during those 2 years based on software and more efficient algorithms. So if you're an algorithmist, or if you're it sounds so old-fashioned to say this, some of you in the audience won't even recognize this term. If you like numerical analysis and linear algebra, those folks at the moment are the heroes who are making us not have to build those power plants. And our understanding is that several different groups in adversarial nations have made some of those advances before we got to them.
And I'll mention just real quickly, Google's just an announcement yesterday of Ironwood, so the next generation of TPUs. And I think it's quite telling that those TPUs are really not aimed at training necessarily, but at inference. They're extraordinarily fast at inference, and they do so at a far less energy cost than others. I think a recognition that one of the great new ways to scale is inference, much more power efficient, and a lot of bang for the buck. 7 petaflops for a single TPU, that's remarkable.
So Jesse, we got a normal question when you can't talk about AI without talking about data.
Yes.
Right, and so this question is about, do we have the data, but do we also have the research on synthetic data, all the other ways that we're working with data? When you think about synthetic data training inference models, it starts to make you a little bit queasy sometimes.
Sure.
Maybe you could talk to that a little bit.
Yeah, keep in mind that with synthetic data, often that's based on and generating new views and new data off of older data. So we see that it's possible to do that. So it's not just entirely purely generated, it's based on prior data. So that's one thing. Also, up until this time, most of the advancements have been from text. And so it's data generated by us in one form or another. But think about the models that are omni models now, that are multimodal. They're learning directly on images, or directly on audio, or directly, especially on video. This is the models learning directly on the world, learning the dynamics. I think of the advancements in weather prediction, where the models are learning directly on the observations and are able to do far better weather prediction than we can actually do using physics-based models, because we just can't compute that much. So yes, we're training on pretty much every scrap of data you can get your hands on. The Llama 4 model, which was just released this past weekend, trained on 40 trillion tokens. Tokens are words or subwords or parts of images. That's an enormous amount. The previous ones were trained, we thought this was amazing, was 13 trillion. So we're talking about immense amounts of information, but now it's not just our text, now it is real world data as well, and that opens up. These are the models learning on the world, not just on what we write about the world.
Can I just mention I'm really happy with your answer there. I do see huge dangers in generating synthetic data in order to train these models, especially if you use the models to generate synthetic data to train the model. That is actually not statistically powerful. You're not going to learn things that you didn't before. So your answer, the fact that you pointed us to the fact that, frankly, we haven't touched 0.1% of all the actual real data available to train from is exactly what I would have said.
Mike, we're on to the ISR question, information surveillance and reconnaissance. So we're drowning in data, ubiquitous sensing, some critical, some purposely deceptive. You know, how do we leverage AI to differentiate with the good data, the poor data, training our systems, and then the most important part, being able to make decisions with confidence to pass down to take further action?
Yeah, so I find this to be a very applicable question, having been an intelligence professional, where in the intelligence world, that the imperative broadly is more data is always better. And I often used to, running the largest intelligence organization in the structure, I often would think to myself, do we really want to embrace this? Is this true, you guys? It's always been kind of a core assumption, but are we getting to the point where volume is starting to degrade speed and scale? Are we getting to the point where we're having trouble understanding what directly translates to value? If you define value as what's going to help me generate insight and knowledge, which is beyond just understanding and I'm able to tell you what's happening. Where I hope AI helps us is this idea of helping us to focus on that data which generates the greatest value in terms of, hey, it generates the insight for us that's most applicable to the problem that we're trying to answer or the problem set we're trying to deal with. It's weird, and to the last part of the question, I agree very much, for example, what Andrew had to say about, hey, looking 5 years down. The thing that I always thought, and we all are captured by our background, so as an intel guy and as a guy who was also an operational commander at the same time, one of the things that I constantly would talk to the team about was, how do we use technology to improve our decision making? Because it's great to have all this knowledge, it's great to have all this insight, but in the end, remember, it's whether we do it autonomously or we do it with a human, it's somebody or something making a decision in the end. And so one of my concerns always was, how do we get faster and better about decision making, whether we decide that the appropriate way to do it is autonomously, or we decide, hey, no, we want a man or woman in the loop and we're going to keep that at a human-based level. It's one of the areas where I'm hoping AI can really make a difference for us, because it's a little bit like innovation. I can remember in the early days when innovation became this very popular trend, we seemed to define innovation as that which enables us to make something faster, that which enables us to generate an outcome faster. We didn't think about innovation in terms of structure, process, ethos, culture. I'm like, all of those areas are foundational to an organization's ability to achieve its outcomes, and all of those potentially could use a high level of innovation. And I look at AI and I go, could we think about the application of this technology more broadly than just, well, it's just going to help us generate a better set of decisions in terms of outcome. And I'm not trying to minimize that, but I'm trying to argue that we need to think about AI and other activities, other technologies, I would hope a little bit more broadly if we're going to maximize their value.
If I might put in just real quickly, just around supporting decision making, and also we're such an interesting point right now with reasoning models. So reasoning models are the standard AI models, but they stop and think before answering, right? And so they generate tokens. So this is sort of behind the scenes. They're considering, weighing evidence, trying out different solutions before they actually respond to you. And so really for the first time, the faster we can run the models to compute, the more thinking and the more consideration happens before they answer. And so this acceleration, and this is called tokens per second. Tokens are compute. And if you can compute many of those, so now for the very first time, we have a very hardware-based way of getting better answers and supporting our decision-making, considering the broad scope of possibilities. And that's by running it on specialized fast hardware, like Ironwood, and like other specialty compute. In my mind, that was the very first time when you can swap out the hardware and have the entire system work better. To mine, that's kind of blowing my mind, but we need to figure out how to leverage that. And so we can tie that into decision making and say, I'm going to train you, I'm going to align you, I'm going to, through reinforcement learning or through fine tuning, I'm going to train you to think in the way that I want you to think. And so I know that you've covered these bases before I have to make my decision. That's a fascinating place to be.
So if I could, I'm going to try to roll up like 3 or 4 questions here, and this normally comes up, this always comes up, which is, comes down to accountability for decisions. And there's a lot of different ways, like, we're in a society where, in the commercial side, it's all about liability. On the military side, it's all about accountability. Like, so when you're using these models, who's accountable? Who's liable? Some people say, well, the commander, I can hear him now, well, I didn't make the model, which goes to the earlier comment, Mike, you're making, like, if you don't know how they work, then I don't want to use them. Talk a little bit about this challenge we're going to have to go through over the next, it's ongoing right now. In fact, it's not. Be interested in your thoughts. All of you, actually. I mean, we have a few minutes left on this.
Yes, so in national security adjacent areas such as fintech, we have to build AIs which are making important decisions about loans or solving anti-money laundering questions. Those worlds happen to come with a whole bunch of existing regulations. And so my experience was there was a lot of extra engineering, but because there were pretty clear statements about the lineage of who's responsible for making a decision, we could engineer around that. And so, for example, if we are trying to use AI against anti-money laundering, the place that the AI was by far the most useful was taking 50,000 leads that a human analyst was meant to look at and prioritizing the top 20, giving the background information so that human analyst would not spend most of their day on the bland things which weren't going to do anything. That, it turned out, we could fit into these careful frameworks that pre-existed. So I like the fact that US and Western generally do have good rules or some rules of engagement for these things, and we should be forced to build AIs within them. And the places that you're going to see the AIs actually being most useful are when they cut out the massive amount of manual search that humans are having to do. And then we can take it to the same places as we had before with the normal rules of engagement.
And I think, look, this a question of accountability and responsibility in the application of technology or acting in response to an input that technology has generated. In some ways, it's not unique. Look, as I was a naval officer, I started as a ship driver. One thing you learn as a ship driver, every time we go into a port, you go through restricted waterways like the Suez Canal, the Panama Canal. We embark these professionals we call pilots, who have extensive knowledge of the local conditions. They understand the harbor, they understand whether it's the English Channel, as I said, some of the famous canals around the world. And there's this long-held maritime debate about, okay, does the skipper still have the responsibility of the commanding officer? Or does the pilot who's sitting there telling you, put the rudder over, increase the speed, do this, do that? And it's funny, maritime law has broadly said, hey, the commander, the master still retains responsibility. There are a couple narrow applications where the environment has been deemed to be so high, so specialized, so demanding that accountability has been transferred to the pilots in a couple really narrow applications around the world. But so my only point is we can learn from other areas. This isn't an idea that's unique to the application of technology. And broadly, I have always believed, and part of it is, I suspect, just being a military individual, was you can never pass accountability. Responsibility is something that's much more easily shifted, but in the end, accountability, hey, that resides with a particular entity, and making sure everybody also understands that is incredibly important.
So maybe we got 4 minutes left here. There's been this discussion on these typhoons, right? And critical infrastructure. Never heard of them. But actually, this question's much broader, is what role does AI play at the risk of U.S. critical infrastructures, but I'd say even global infrastructures being compromised? Like, how could AI help here in protecting critical infrastructures, kind of going to what Sam was talking about, right? To make the world just a better place.
So certainly, from a cybersecurity standpoint, is in my previous life tasked with defending critical infrastructure in the nation, we were interested in both how adversaries might use technology to try to gain advantage in their attempts to either interdict, disrupt, destroy. At the same time, we were trying to figure out how can we apply technology in a way that gives us defensive advantage here, that forestalls their ability to apply this technology. I will say the offensive side, and if we just look at AI and its application, the offensive side is probably still ahead of from a cybersecurity perspective, the offensive side is still probably ahead of the defensive side. I think that dynamic is changing, and I expect it to change more broadly. That also goes to this whole cultural thing about, so for example, for a lot of authoritarian states, they have no qualms at all about using AI as a tool to penetrate networks and potentially cause damage. As a defender in a democratic state, you're thinking, well, wait a second, what level of autonomy here are we, again, to these other things we've already talked about? You see the same thing play out in cybersecurity. Bottom line, I think you're going to see AI viewed more aggressively as a tool for cybersecurity in terms of defense of critical infrastructure and networks more broadly. The thing I worry about a little bit is right now we are very obsessed with AI. I don't mean that as a negative. I just mean it as an observation. I worry a little bit more about when you combine quantum and its advanced computational capability that's coming down the road with the ability to learn from. So quantum is theoretically going to give us this ability to generate new knowledge at a massive computational level we've never seen before. You combine that with AI and the ability to learn from knowledge. I'm going, you put these two things together. If we think we've seen disruption, change, and this is creating angst in the world we're in now, I'm going, man, you put these two things together, the world we're going to be dealing with is going to be much more complicated, much more challenging. I do worry a little bit that we're not thinking broadly enough. We're viewing AI as an end and all, be all of itself. And I worry a little bit about, no, it's one technology, potentially combined with some other things, becomes even more challenging. Just an observation.
I'll quickly mention that one thing that distinguishes national security from other commercial areas is our AIs cannot be predictable. As we all know, when you're doing force protection or engaged in an adversarial campaign, you can't just run the AI and it tells you the optimal thing to do and you do it, because that is predictable. So specifically in the national security world, I want to see more work on game theoretic decision making, where the AI has to come up with a probability distribution of next actions so that the enemy can't predict what we're doing and deal with it. Similarly, we have to expect that the enemy is using this kind of game theory as well.
Anything last?
I think it's important to figure out the role of AI and to use it to complement our existing strengths, and also to recognize that it also opens up new New surfaces, new threat surfaces. Just want to point this out. So DeepSeek, for example, is a very popular model. People are including this in agents right now. But DeepSeek is also just wide open and can absolutely be compromised. And the more that we hand over control to agents, and especially with insecure models, then that means that opens up another attack surface. So we just have to keep that in mind. And so it gives us capabilities and opens up vulnerabilities at the same time.
Okay, Jesse, Mike, Andrew, thank you very much. How about a round of applause here for our panelists?